we're going to discuss the types of statistical tests and how to solve them in PSPP. For this presentation, we're going to use PSPP to solve for the statistical test and Excel to encode your data. Problems in this presentation are found in Modern Business Statistics with Microsoft Excel. So, as a review, these are the steps in hypothesis testing. Number 1, state the null hypothesis and the alternative hypothesis. Choose the level of significance. Number 3, select the appropriate test statistic and establish the critical region. Number 4, collect the data and compute the value of the test statistic from the sample data. And number 5, make the decision. So the Kruskal-Wallis H test, sometimes called the one-way ANOVA on ranks, is a rank-based non-parametric test that can be used to determine if there are statistically significant differences between two or more groups of an independent variable on a continuous or ordinal dependent variable. It is considered a non-parametric alternative to the one-way ANOVA and an extension of the Mann-Whitney-U test to allow the comparison of more than two independent groups. The H test is used when the assumptions for ANOVA aren't met, like the assumption of normality and assumption also of equality of variances. So if the your ANOVA result will show a Leven's equality that are not equal, then you will proceed to run a Kruskal-Wallis test instead of an ANOVA analysis. Okay, so since the ANOVA assumptions are not met. Okay, so this is Kruskal-Wallis H test. So if you're running this one is similar to Mann-Whitney. So if there are only two independent groups, the result is actually Mann-Whitney result. Okay, so this test determines whether the medians of two or more groups are different. Like most statistical tests, you calculate a test statistic and compare it to a distribution cutoff point. So the test statistic used in this test is called the H statistic. The hypothesis for the test are the population medians are equal. Alternative hypothesis, the population's medians are not equal. Or there is no difference between the population medians. Then, for alternative hypothesis, there is difference between the population medians. Okay, so the Kruskal-Wallis H test will tell you if there is significant differences between the groups. However, it won't tell you which groups are different. So for that, you'll need to run a post-hoc test. So you can use t-test for independent samples or Mann-Whitney-U test. So you compare each independent group to one another. Okay, or you can run up. Okay, let's just run that one. Okay, so examples. The Kruskal-Wallis H test can be used to understand whether the cholesterol level based on a continuous scale differed based on diet plan chosen by respondents. So the dependent variable will still be your cholesterol level, and your plan A, B, and C are the independent variables. So same with your ANOVA. Okay, but then we do not assume here that it's normally distributed. Then it can be used to understand whether extent of customer satisfaction towards a certain medical laboratory where the customer satisfaction are measured on an ordinal scale, differed based on employment. So the independent variable would be your customer satisfaction measured in a 5-point scale from very satisfied, highly satisfied to not satisfied. And the independent variable would be employment, which has three independent groups: employed, self-employed, and not employed. Okay, so 3 or more independent groups. And ordinal, so from 1 to 5. Okay. So assumptions. The dependent variable to be measured is at least ordinal or ratio. Okay, so either you use your Likert scale or it's the scale. So customer satisfaction, intelligence, weight. The independent variable should consist of 2 or more categorical independent groups. So for example, civil status, so single, married, or widowed, and year level. So first year, second year, third year, fourth year. There should be independence of observations, meaning we're comparing 3 or more unrelated groups. So kung R siya sa group 1, wala na siya sa group 2. Then, the variables are not normally distributed. So this is the difference with your ANOVA. And also, if you're going to run an ANOVA analysis and you see that the Leibniz test for equality variances is not met, then you can use Kruskal-Wallis H test for the test instead. Okay, so procedures in PSPP is the same with your man-Whitney U. So encode data for independent and dependent variables in PSPP. You click on Analyze Non-Parametric Statistics with K Independent Samples t-test. And dependent variable as a test variable and independent variable as the grouping. So define groups with lower limit and upper limit using rank of independent variables. So ang lower rank is your lower limit and the upper ranks is your upper limit. Okay, so example, the better selling candies are often high in calories. Assume that the following data show the calorie content from samples of M&M's, Kit Kat, and Milky Way 2. Test for significant differences among the calorie content of these three candies at alpha equal 0.05 level of significance. What is your conclusion? So our alternative hypothesis is that there is no significant differences among the calorie content of these three candies. Our alternative hypothesis is there is significant difference between the three candies. Your level of significance is 0.05. Our test statistic is now Kruskal-Wallis H test. As example here, the given data are not equal. Sample here, the given data are not equal. Okay, and there are only 4, 5, and 6. So you cannot assume that it's normal because the total of this one is 15. Okay, you cannot assume normality. Also, okay, so we use Kruskal-Wallis H test. And we do your test. Okay, so this is now your data set. So in your PSPP, simply type candy brand and calorie content. Okay, so for variable, this is candy brand and calorie content. So for label, you have 1 for M&M's, 2 for Kit Kat, space, Kit Kat, and 3 Milky Way. So this is now okay. Decimal value is 0. The calorie content is in whole numbers. So this is now nominal. And it's still scale since it's a continuous variable. Okay. Then you simply copy this one. So again, M&M's, Kit Kat, Milky Way 2. So there are only 15 respondents. Okay. Then again, analyze non-parametric test, key independent samples. Okay. Our test variable will be the calorie content and our grouping variable will be your candy brand. So you define group with a lower limit as M&M's and upper limit as your Milky Way 2. Okay. And since this is Kruskal-Wallis H test, you click Kruskal-Wallis H test. And then you click OK. So for Kruskal-Wallis H test, calorie content for 5, 6, symptomatic, there is significant difference because this is 0.034. So there is significant difference between the candy brands. Okay, so there is significant difference between the three candy brands. And since we do not know which candy brand has significant difference. Either you do a Mann-Whitney or you do a one-Whitney test, meaning compare only two variables. For example, this non-parametric test, K independent samples. So for the defined groups, let's say your lower limit is MMs and your upper limit will be KitKat. So you only compare MM and KitKat. Okay, so ignore nyo lang na ang Milky Way 2. And this is now okay. Okay, so for this, asymptomatic sig is 0.462, which is greater than 0.05. So meaning there is no significant difference between MMs and KitKat. Okay, there is no significant difference between MMs and KitKat. And again, another non-parametric test, independent samples, and defined groups. So MMs. So let's have this one as KitKat, then this one as your Milky Way. Okay, so you only compare B and C, so ignore nyo lang na ang A. And this is okay. Another result. So KitKat and Milky Way, 0.045, which is less than your 0.05, so meaning there is significant difference between KitKat and Milky Way. Okay? Significant difference between KitKat and Milky Way. Okay? So we have compared MMs and KitKat. So that's your A and B. Then this is now B and C. So B and C na lang. A and C na lang. And since we cannot do that using your Mann-Whitney, so you can do either you can try this one, independent samples t-test. Of course, the variable defined groups, since duha lang, you can have MMs and Milky Way. Let's try if this will run. So this is 0.05. Okay. Content, MMs and Milky Way. Vin's test for equality is 0.905. So their equal variance is not assumed. Equal variance is not assumed. The sigtail is 0.028. So there is significant difference between your MMs and Milky Way. Okay, but that is actually less accurate because for test we are assuming that the data is normally distributed. So if you can also delete or you do this manually or you remove it entirely. This thing, let's your cases one by one. So hindi siya pwede nga as a whole. So let's clear cases. Then you can now do this non-parametric test for K independent samples. Then you define groups. So MMs and Milky Way, this wala naman value for KitKat. Just simply continue and this is now okay. So the result is that it's 0.025. Okay, so there is significant difference between your MMs and Milky Way, which is the same for your independent samples test result. Okay, so that's Kruskal-Wallis test and it's post-hoc. Okay, so either you use your Mann or use your test, but I suggest that you use your Mann-Whitney.